Welcome to our lesson on the Poisson distribution. This is an important concept in probability theory, especially for students in Class 12 and those preparing for university entrance exams like CUET. So, what exactly is the Poisson distribution? It's a discrete probability distribution that represents the probability of a given number of events occurring within a fixed time interval or space. When these events occur at a known constant mean rate and independently of the time since the last event. Let's look at some real-life examples where the Poisson distribution is applicable. Number of customers entering a shop in 1 hour, number of calls received by a call center in 30 minutes, number of road accidents in a city in a day, number of typos on a page of a book, number of emails received in an hour. The Poisson probability mass function is given by P of x equals lambda to the power x times e to the power negative lambda divided by x factorial, where lambda represents the average number of events in the given time interval. X is the number of occurrences we're interested in. E is the base of natural logarithms, approximately 2.718. Let's understand this formula step by step. Let's visualize the Poisson distribution for different values of lambda. When lambda equals 1, we see that the probability is highest for 0 and 1 occurrences, and then decreases rather quickly. When lambda equals 3, the distribution shifts to the right, with highest probabilities around 2 and 3 occurrences. When lambda equals 5, it moves even further right, with 4 and 5 occurrences being most probable. And for lambda equals 10, we see the distribution becomes more symmetrical, resembling a normal distribution. Now, let's discuss some key properties of the Poisson distribution. First, for a Poisson distribution, the mean, or expected value, equals lambda. Second, the variance also equals lambda. This means the standard deviation equals the square root of lambda. The Poisson distribution is right-skewed when lambda is small, but becomes more symmetric as lambda increases, approaching a normal distribution. Lastly, the Poisson distribution has an additive property. If x and y are independent Poisson random variables with parameters lambda 1 and lambda 2, then x plus y follows a Poisson distribution with parameter lambda 1 plus lambda 2. Let's work through some examples to better understand the Poisson distribution. Example 1. A call center receives an average of 6 calls per hour. What is the probability of receiving exactly 4 calls in the next hour? We have lambda equals 6, and we want to find P of x equals 4. Using the Poisson formula, P of x equals 4 equals 6 to the power 4 times e to the power negative 6, divided by 4 factorial. This gives us 6 to the power 4 equals 1,296. E to the power negative 6 approximately equals 0.0025, and 4 factorial equals 24. So P of x equals 4 equals 1,296 times 0.0025 divided by 24, which equals 0.1339, or about 13.4%. Example 2. A bookstore sells an average of 3 copies of a particular book per day. What is the probability of selling at most 2 copies of the book tomorrow? Here, lambda equals 3, and we want to find P of x less than or equal to 2, which equals P of x equals 0 plus P of x equals 1 plus P of x equals 2. For P of x equals 0, this is 3 to the power 0 times e to the power negative 3 divided by 0 factorial, which equals 1 times 0.0498 divided by 1, which equals 0.0498. For P of x equals 1, this is 3 to the power 1 times e to the power negative 3 divided by 1 factorial, which equals 3 times 0.0498 divided by 1, which equals 0.1494. For P of x equals 2, this is 3 to the power 2 times e to the power negative 3 divided by 2 factorial, which equals 9 times 0.0498 divided by 2, which equals 0.2241. Adding these up, 0.0498 plus 0.1494 plus 0.224, 1 equals 0.4233, or about 42.3%. Example 3. A typist makes an average of 2 errors per page. What is the probability that on a 5-page document there will be exactly 6 errors? For 5 pages with an average of 2 errors per page, lambda equals 5 times 2, which is 10. Using the Poisson formula, P of x equals 6 equals 10 to the power 6 times e to the power negative 10 divided by 6 factorial, which is approximately 0.0631 or 6.31%. B. at least 15 errors, p of x greater than or equal to 15 equals 1 minus p of x less than 15. This is a more complex calculation, but using the Poisson cumulative distribution function, we get p of x less than 15 approximately equals 0.9513. So p of x greater than or equal to 15 equals 1 minus 0.9513, which equals 0.0487 or about 4.9%. The Poisson distribution is related to other probability distributions. It can be viewed as a limiting case of the binomial distribution. When the number of trials n approaches infinity, the probability of success p approaches 0, and n times p remains constant at lambda. As lambda increases, the Poisson distribution can be approximated by a normal distribution with mean lambda and variance lambda. Let's summarize what we've learned about the Poisson distribution. It's used to model the number of events occurring within a fixed interval. The formula is p of x equals lambda to the power x times e to the power negative lambda, divided by x factorial. Both the mean and variance equal lambda. It's applicable in situations with rare events where the probability of an event in a small interval is proportional to the length of the interval. Thanks for watching. I hope this helps you understand the Poisson distribution for your exams.